Good day to all of you. Today we shall discuss memory hierarchy with respect to speed, size and cost. Our acknowledgement to author Karl Hamacher, author of book with title Computer Organization 5th edition. The content of discussion is taken from this book. Computer is a digital device which processes the information. So computer has processor as its heart and brain which actually process the given information. So the program and data in the figure shown here, it will be stored in the main memory at the time of execution. Main memory is the semiconductor memory, but it is volatile. When power is switched off, it is erased. Hence, the data and instructions or say program and data are stored in hard disks permanently. That is secondary storage devices. They are non-volatile. Even power if switched off, the program and data will be stored permanently. But when they are chosen for execution from secondary storage device, that is hard disk, it is to be loaded in primary memory, that is main memory. So processor accesses main memory for data and instructions and hence execute the program. And in the figure here, one more memory is shown, cache memory. Each time if processor is made to access main memory, the access time will be larger. Hence, execution time is more. We say that processor performance is poor. To increase the speed of execution, some part of memory is implemented on chip with the processor. So, cache memory is faster memory. Because it is nearer to processor than main memory, some part of the program and data are brought from main memory into cache. So when given for execution, processor instead of going to main memory, it can access it directly from cache. Hence access time is reduced and speed of execution is increased. That is, performance is improved. Here cache memory is treated as part of processor. So the processor and relatively a small cache memory can be fabricated on a single IC, integrated circuit chip. Because space is limited, though cache is faster, it cannot be made bigger. Okay. So the cache memory which is on chip with the processor is called as primary cache. So far the processor was accessing for needed data and instructions from main memory. Now because they are made available in the cache, now the same instructions and data are directly accessed from the cache. Because cache is nearer to processor than main memory, very fast access can be done and hence fast execution. If suppose the same instructions or data are accessed frequently, because a copy is maintained from main memory into cache, repeatedly now processor can access it from cache itself. So in case of looping instructions, a set of instructions are repeated. They are now made available to processor in less time. Hence, the instructions are executed very quickly. So this discussion shows that apart from processor in the computer, what memory was present, not just main memory, one more unit cache was made available. That is a special type of memory which is faster memory when compared to main memory. Both are semiconductor memory only. Secondary storage device or permanent storage device, that is hard disk, they are magnetic devices. But these main memory and cache are semiconductor memory. They are faster than hard disk. Okay. Because primary cache is on chip with processor, it is faster than main memory. So like this, instead of providing one bigger unit of memory, several smaller units of memory are provided. So This organization of memory is called as memory hierarchy at different levels is called as memory hierarchy. The main aim is to minimize the access time in the computer system design and hence to increase the speed of execution, improve the performance of the computer. So with respect to main memory, the aim is to increase the speed, reduce the cost, reduce the size of memory and improve the performance of a computer in terms of reduced time of execution. So one more term is there, that is code refactoring. Means whatever code is given, that is computer code is there, that is rearranged, preserving functionality, then improvement in the design of software, that is improvement in the execution time is possible. Then this memory hierarchy helps. To take the advantage of memory hierarchy, the cooperation of programmers, hardware, compilers and operating system is needed. Programmers are responsible for moving data between disk and memory through file input-output operations. Hardware is responsible for moving data between memory and cache. Memory means here main memory and cache. So file IO is responsible for data movement between hard disk and main memory, and hardware is responsible for moving data between main memory and cache. The compiler should be optimized, means they must reduce the program execution time, reduce the necessity of storage space and required power, and memory footprint. Memory footprint means the amount of RAM that is used during program execution. To reduce all these, the compilers must be optimized. Means the compiler's design must be able to take the advantage of hardware as to use cache and registers efficiently. There are multiple levels present in the memory hierarchy. Each one has different size, different cost, etc. They are registers, cache, main memory, secondary memory. In all these cases, accessing of data is not similar. Some are faster and some are slower. Hence, these vary in speed, size and cost. So, memory hierarchy means organization of memory for saving the access time. The entire computer memory can be viewed as hierarchy as shown in figure here. At the top of hierarchy we have registers. They are fastest. They are on chip with the processor. They can execute very fast, but they are very costly. Hence one more memory is made present which is less costly, but it is comparatively little bit slower, but it helps to reduce the cost. That is primary cache, L1 level of cache. Cache memory is a special memory. It is of high speed. It is small in size because it is very costly when compared to main memory, but less costly when compared to registers. So they are faster memory elements. So whatever program is under execution and loaded into main memory, a copy of that is stored in cache. So primary cache means the cache memory which is present on chip with the processor. It is L1 level of cache. So it is almost equal to registers in speed, but less costly when compared to registers. Hence, registers, because very costly, are made available in small number, but comparatively little bigger size primary cache is provided, but not more when compared to secondary cache, because on chip space available is less. Hence part of the cache which is a faster memory, that is outside the processor IC, that is called as L2, that is secondary cache. Secondary cache is placed between main memory and primary cache. It is not there on chip with processor IC. It is external to processor IC. So this main memory is called as random access memory. This cache is also random access memory. Both are semiconductor memories, both cache and main memory. But cache is faster because it is made up of SRAM ICs, static random access memory integrated circuits. Main memory, which is huge in size but little bit slower and but less costly, that is made up of DRAM ICs, dynamic random access memory ICs. This main memory is also called as primary memory. As already pointed, it is semiconductor memory. At the time of execution, the program is loaded from secondary memory to main memory. Main memory is volatile. If power is switched off, whatever program or data is loaded, that gets erased. The operating system controls the usage of this memory. It gives instructions like when programs are to be loaded into RAM from hard disk, or where they are to be located in the RAM, that is in main memory, and when they need to be removed from RAM, that is main memory. This everything is controlled by operating system. The CPU can directly access main memory but not hard disk. Hence, for CPU or the processor, for execution from hard disk, it is loaded into main memory. Because of requirements of speed, part of that is copied into secondary cache and then into primary cache. During execution, processor accesses directly primary cache and execute part of the program. And if it is repeatedly done, it will be accessed by primary cache only. So next time when it refers, if it is not available in primary cache, it is loaded from secondary cache. So in secondary cache, from where it is copied? From main memory. Anyway, the program under execution has to be in main memory only. From there, for fast execution reason, it is brought to cache. Main memory is bigger in size when compared to cache, because what big programs we have stored in secondary memory device, that is a hard disk, at the time of execution we must be able to load it in main memory, because some of the programs happen to be bigger and bigger and data also happens to be large, then main memory size required is also more. Cache memory is small in size but faster, so it is made up of SRAM, as already told earlier. Because they are costly, main memory is not made up of SRAM ICs, it is made up of less costly DRAM ICs. Because of lesser cost, they can be provided in bigger sizes. So the choice of RAM chip for a given application depends on several factors. The factors considered are the cost, speed, power dissipation and size of the chip. So the last part of memory, which is far from processor, that is secondary memory, which is permanent storage device, that is magnetic disk here. So here it is non-volatile, means once stored, program and data are maintained in the disk. But processor cannot access this directly. These hard disks are bigger in size and less costly, but they are the slowest memory devices. Example for secondary storage devices are hard disk, then solid state devices, flash, optical drives, then universal serial bus, that is USB drives. These are some of the example of secondary memories in the computer. So if we refer to the figure here, all different memory units in different hierarchy we can see. So which is nearer to processor? Registers. They are the fastest but limited in size because of more cost. Next one is primary cache. It is on chip with the processor L1 level cache, which is faster but not as fast as registers, but less costly when compared to registers. Because size or space is limited on processor IC, part of the cache is implemented outside the processor IC, that is secondary cache or L2 level cache. Cache are the special memory which are faster. Then we have main memory or primary memory, which is bigger in size when compared to cache, but less costly and less slower also. The last one is secondary memory. Example, magnetic disk or hard disk. They can store huge programs and large amount of data permanently. They are non-volatile. Even if switch is made off, the data and instructions are retained in the magnetic disk. They are less costly, available in bigger sizes, but they are the slowest memory units. So these three arrowed lines, as we move away from the processor, we can have increased size of memory, then cost is less, but at the same time speed is also less. So increasing speed, increasing cost per bit, those two arrowed lines if you consider, as we move from secondary memory to primary memory, that is main memory, cache and then to registers, the speed is increased, but at the same time cost per bit is also increased. Hence, though bigger sized memories are required, fast memories are required, they cannot be provided as needed in bigger sizes because cost is more. So one has to judicially decide between the cost and speed. Finally, we can conclude that memory is mainly used to decrease the bit cost and access frequency, that is reduce the number of processor accessing main memory every time and reduce the access time and increase the capacity of the memory. But it is up to the designer how much they need these characteristics for satisfying the necessity of their consumers, because no consumer likes to buy a costly equipment. That completes the discussion regarding memory hierarchy. So we shall recall from the discussion on memory hierarchy what are the memory system considerations. Very large disks are available at reasonable price. They are used extensively in computer systems for permanent storage, that is hard disks, but they are slower when compared to semiconductor memory units. So example for secondary storage devices are magnetic disks, tape and optical disks. They are very less fast, less costly, but can be bigger in size. Then primary memory is made up of DRAM ICs, dynamic random access memory integrated circuits. But these are faster but more costly when compared to hard disk. Hence they are provided in smaller sizes when compared to hard disks. DRAMs are more expensive when compared to hard disk but faster. Cache is very fast when compared to main memory. It is implemented using SRAM chips, static random access memory integrated circuits. Because these are very expensive, because the number of transistors used per every cell means which stores 1 bit, are 6 transistors. The circuit is complex and consumes more transistors, hence they are very expensive but faster. Because of cost reasons, it is impractical to build a large memory using SRAMs. Hence, main memory size is smaller and cache memory size is even smaller. Main memory is made up of DRAMs, but cache memory is made up of SRAMs. Hence, cache memory size is smaller. The registers are the fastest but very few are provided in the processor because of cost reasons. That is the revision of the content of memory hierarchy. We shall consider a question which was given in one of the competitive examination. Which among the following is the fastest? ROM, read-only memory, flash drive, cache memory, RAM. So it is cache memory. It's a high-speed storage area. It is used for temporary storage. It is very small but is of high speed. It acts as a buffer between RAM, that is main memory, and processor, that is CPU. Some extra information. Flash drive is popularly known as pen drive. A pen drive is also called as USB flash drive. It is a data storage device that includes flash memory with an integrated USB universal serial bus interface. The RAM is a random access memory, is a read-write memory. The CPU can change the contents of RAM at any time. RAM is volatile. RAM means here main memory or primary memory. At the time of execution, what program and data has to be there, that part of memory. So read-only memory is non-volatile and retains its information even after the power is turned off. That completes the discussion regarding memory and memory hierarchy. Organization of memory, that is memory hierarchy. I hope you understood. Thank you.